All right, this is still from section 10.1, extra example number 2, hearing loss. Are teenagers going deaf? In a study of 3,000 randomly selected teenagers in 1988 to 94, 15% of those 3,000 showed some hearing loss. In a similar study of 1,800 teenagers in 2005 to 2006, 19.5% of those 1,800 showed some hearing loss. There's the source. Does these data give convincing evidence that the proportion of all teens with hearing loss has increased? And then part B is, between the two studies, Apple introduced the iPod. If the results of the test are statistically significant, so if we reject H0 at the right significance level, can we blame iPods for the increased hearing loss in teenagers? Okay. So, hearing loss. We will do state, plan, do, conclude. Even more important for hypothesis tests, state. Okay, so let P sub 1 equal proportion of all teenagers with hearing loss in 2005 to 2006, and then let P sub 2 equal, same thing, I'm going to use quotes, in 1988 to 1994. Okay, and then our test is H0 is that the difference in proportions is there's no change, and our alternative hypothesis is that the difference is greater than 0 because we're trying to show that there was hearing loss greater than 0, and we're going to always, the default is alpha is the 0.05 significance level, that alpha is 0.05. So the plan is to perform, so you have to state the type of test, a two sample Z test, because it's proportions. If, alright, and now from today's assignment forward, on only the homework, not on the test, not on the AP test, you can, if you feel like you know how to state the conditions, skip them and write R and I. Only on the homework, and only if you know what you're doing, you're confident you're not going to miss it. And keep in mind that in this case, for normal, it's not NP greater than equal to 10. It's that you need at least 30 for the central limit theorem for means. And there are at least 30, because if you take the 15% of 3,000 is at least 30, and 19.5% of 1,800 is at least 30. So I'm going to let you skip those on your, starting with today, assignment number 22, if you feel like you're good. But not on a test, never on a test. Okay, so done, plan is done. Do. Okay, we're going to need to use, well, I'll write out the formula first. Even though on the homework and the test you don't have to, I just want it there so you can see it in the examples. So we need to find the test statistic. So Z equals, and we would do the difference of the sample proportions minus 0 over, this is from your notes, the pooled proportion P sub C 1 minus P hat sub C over N sub 1 plus P sub C 1 minus, so when we use the pooled proportion, it's the same for both of these fractions. Okay, so that's what we're using. So the pooled proportion is this. This is how you find it. It's very, very easy. It's like this, and I want to use this. P sub C hat is, you just take the two samples. So it would be 450 plus 351 over 3,000 plus 1,800. And the 450 comes from, that's 15% of 3,000 that showed hearing loss. The 351 is 19.5% of 1,800. So that's the pooled proportion, which should come out to 0.167. So wherever you see that, you're going to plug that into the formula. So you get, plugging everything in, you get Z equals 0.195 for 19.5% minus 0.15 for 15% minus 0 over square root of 0.167 that we just found times 1 minus 0.167 over 1,800 plus, minus, plus 0.167, 1 minus 0.167, that does not look legible, 1 minus 0.167 over 3,000. And then if you have any problems typing that in your calculator, and you please ask me for help. I'm not judging you. And you should get 4.05 for your Z value. And that is large. And there's not going to be much area under the curve there. So I'll tell you, you can use table A, and I'll show you how. Or you can just say normal CDF on your calculator to find the p-value. Normal CDF, and we want to go from 4.05 up to infinity. That's what you would do on your calculator, and you'll get your p-value of 0. So basically that's saying there's practically no chance that if H naught is true, we would have gotten a sample like we did. So that means we can reject H naught, because there's like no chance we would get a sample like that. So and if you're using table A to look up 4.05, do you see how? So if you're using this, 4.05 isn't even on here. Like the numbers are really big, but I said it's 0. Right? Why is it 0 if the numbers are really big? Exactly. You're looking for the area to the right, not to the left. So you would do 1 minus this number, and it's so big that it's just 0. Or you use your calculator, and then conclude that, the most important part, conclude that so there's two sentences you need to use on the conclusion. So first is, since the p-value is less than 0.05, we reject H naught. But you can't leave it at that, because that's not putting it into context of the problem that we're solving. So you need to continue with another sentence. We have convincing evidence. Convincing evidence that the proportion of all teenagers with hearing loss has increased. With hearing loss has increased from 1988 to 94, my time, to 2005 to 2006. So that's your conclusion. Now about the iPods, can we conclude then that the iPods caused hearing loss? What do you think? Okay, good. No. We didn't do an experiment where we randomly assigned some teenagers to listen to iPods and some to not. So there's no way we can draw a conclusion about iPods being the cause. It might be rock concerts or something else. Okay. So no, since we didn't do an experiment, since we didn't do an experiment where we randomly assigned some teens to listen to iPods and other teens to avoid listening to iPods, we cannot conclude that iPods are the cause. iPods are the